So for today we have this circuit, and our job is to find the voltages between these dots, between these dots. So AC, then we have AD, then we have CF, and we have A to B. Okay, and we will have to use here voltage divider. So just let me to write. So we will use this rule. We will not use the current to calculate. So our first step is to find the sum of all these voltages here. So ET is equal, or say total. So ET is total, but let's say first to find the marks that we used to. So here is minus, here is a plus, okay. Then we have here minus, plus, okay. Also we have plus here, minus here, then we have minus here, plus here, minus, plus, plus, minus, then we have minus and plus, okay. Okay, so that is one thing. Next thing is that we have to find voltage drops here, that we OR1. Next one will be OR2, and we will have here OR3. Okay, so let's solve this circuit. All right, so we use the rule that we already learned. So we have here minus EI1 plus I2 and plus I3. Okay, so that will be, we have minus 2 plus 3 plus 4, and that will be 5 voltage. Okay, so before we continue to work using a voltage divider rule, we need to calculate a total in this circle, on this circuit, and that since we have series, then only we will add each other, R1 plus R2 plus R3. RT is equal, we have 10 plus 30 and plus 40. So RT here in R is 80 ohms. So let's go to voltage divider to find OR1. So OR1, it is, we use the divider, and then we say, so here goes the resistance that we looking their voltage drop, so it will be R1, there will be R total, and we will multiply with ET here. So this is a 10, here is 80 multiplied with 5, and that will be 0.625 voltage. Next one is for the resistance 2 voltage drop. Then will be, we will use R2 above the line, and under is RT, with multiply with 80. Okay, so it's total voltage. Okay, it will be 30, the 80 multiplied with 5, and our result will be 1.875. I'm not losing time for calculating, so I'm just writing the final result, so it's easier for you. Just divide this 2 and then multiply with this, or you can multiply with this and then divide this by this, but the same thing. If you have a question, please ask, comment below, and I will answer. Next one, R3 is, so we have to use R3, R total is equal, so we have 40, 80, RT at 80, then multiply with 5, and our result will be 2.50 voltage. Okay, so now when we have all voltage drops here, we can use that to calculate our voltage or potentials. So VC, so between A and C point, we have some, since we know that here is minus, so minus E81 and minus OR1. Okay, so that will be minus 2 minus 0.625, and that will be, the final will be minus 2.625 voltage. Okay, next one is VID. Okay, between A and D we go the same way, so minus A1 minus OR1, then we have plus A2, so that will be, to calculate, we say minus 2 minus 0.625 and plus 3, and the final result will be, here in this case, 0.375 voltage. Okay, next one is between C and F. CF is equal, so we go here, it will plus A2 minus OR3 and plus R3. Okay, then we just use we have 3 minus 1.875, and we have plus 4, and that will be 5.125 voltage. And final but not last but not least, VEB, so between A and B dots, so that we have, say, A3 minus OR3 minus A1, so we have 4 minus 2.50 and minus 2, and we will have 0.500 voltage. We can use here other way, so we use this one, so now we'll use this one here, and we'll have to got the same result. So VB is equal, so let's say here is a plus, so UR3 minus A2 plus UR1, so we have 2.50 minus 3 and plus 0.625, it will be 0.5005. That's the idea of this use of voltage divider. It's a little longer example, but I think that you can follow and you will understand. If you have any question, please comment below and I will try to explain. Bye.